This video is on section 2.4. There's two parts to 2.4. This is part 1. It goes along with homework number 14. This is analyzing graphs of quadratic functions. Now I want you to listen very carefully because this is going to sound a lot like a section we did in chapter 1, the section where we talked about parabolas, V-shaped graphs, square root graphs, cube graphs, except this time we're only talking about parabolas, x squared. These parabolas, these equations are going to be in what we call a vertex form, meaning they're going to be set up the way we want them to. The equation itself will tell us a lot of information. Now, in this next little paragraph, there are a lot of variables, but you just hold on because that's not going to be, we're going to talk ourselves through that. The equation, if everything were multiplied out, of course, is ax squared plus bx plus c equals 0. If it's in vertex form, it has been factored so that we have y equal a times x minus h squared plus k. Now, what I want you to know is that this a, first of all, is going to tell us if the graph opens up or down. If a is positive, the graph opens up. If a is negative, the graph opens down. Now, you're going to also see that as a becomes something other than 1, the graph will either open wider or it'll shrink and get tighter, and that's really not going to affect us that much, I promise. Again, as we did in chapter 1, we're going to be looking for the vertex, which is an ordered pair. We're going to take the x value from this parentheses, and I told you in chapter 1, when you take a value out of the parentheses, it comes out as the opposite. This number on the end is going to be my y value, as it is. The axis of symmetry. For just a moment, think of a parabola. An axis of symmetry is a line that cuts that graph in half so that the half on the left side matches the half on the right side. This is a vertical line, and again, remember, vertical lines are named with x equals some number. Now, if you will listen very carefully, this is going to be quite easy. All of your problems will not ask all of these questions, but they'll ask some of these questions, so we're going to go over this in these next problems. I'm going to give you an equation, y equals x minus 1 squared minus 4, that is in vertex form, as we talked about. I've already given you the graph. Let's find the information. If I want the vertex, remember I'm looking for an ordered pair. To find the x, I'm going to take the number out of the x, negative 1, it becomes a positive 1. For y, I take the number sitting on the end, negative 4. Now remember, the axis of symmetry is this line that runs through this graph and splits it in half. A vertical line is always named x, and you're going to use the only x that you have in that problem, which is 1. The domain of this problem is always all real numbers, negative to positive infinity. Go back to section 1.2. In this equation, you have no radical, you have no fraction, so all real numbers. The range, if you remember, range is y. And if you will look at your graph, in this graph, every single y falls above this vertex, falls above the vertex. So it's either greater than or equal to this point. This, and range is y, remember, so we're talking about this y number, negative 4. Now, let's put that in interval notation. If y can be equal to negative 4 and then has to be larger, we would put a bracket at negative 4 and go to positive infinity. Now, your problems will say, do you have a maximum or a minimum? If you look, this graph has a low point. This is the lowest point. That's called a minimum. Now, this is the way they'll ask you this in some cases. The minimum is at what y value? Well, it's negative 4. And that occurs when x equals 1. So here is the minimum point. Now, one thing we did not talk about, but if you'll notice, there is not a negative sign in front of this equation. Therefore, this parabola opens upward. That possibly could have been a question. Okay, let's look at our second one. Y equals negative, which tells me it opens downward. X plus 3 squared plus 2. The vertex is an ordered pair. Take the x out, change its sign, use the y. The axis of symmetry is a vertical line. Vertical lines are named x. The only x you have is in your vertex. The domain of all parabolas are all real numbers. The range, now in this case, the range, the y's, are all below this point. All y's are below this point, so they're less than or equal to your y value, which is 2. Or let's write that as an interval. The lowest y on this graph is negative infinity, and it goes up to a high y of positive 2. This graph has a high point, has a maximum. The maximum is at what y value? 2, when your x is at negative 3. Now, I'm going to show you some graphs such as they will appear on your homework, some matchings, showing you that you're really not going to be doing a lot of graphing, you're going to be doing some matching. The first thing I want you to notice is that because of this negative, my graph is going to be turned down. Therefore, I can forget the upward graph. My vertex, getting this number out, is a positive 3. There's no number on the end, so 0. I'm looking for a graph turning down that has its vertex at positive 3, 0. This is not positive 3. This one could be positive 3. This one is negative 3. So it is B. In number 4, I'm looking for a graph. This is positive that opens up with a vertex of negative 4, 7. Opens up. So again, I am going to disregard this graph and this graph because they open downward. I'm going to look for negative 4, 7. It could be this one. Negative 4, 7. It's not even that one. Now, you notice that had a 1/2 in front of it, which means that that graph is a little thinner than an equation would be with a 1, but we did not feel that at all. In number 5, the plus 2 says that it opens upward. The vertex is negative 6, 1. It opens upward, so I'll disregard the downward graphs. I'm going to go to negative 6, 1. It's not that one. Negative 6, 1. It would be A. And one more. Number 6, I have a negative. The graph turns down, so I'm going to disregard the up graph. I have a negative 2, negative 7 vertex. Negative 2, negative 7, it's not that one. Negative 2, negative 7, it's not that one. Negative 2, negative 7, it would be graph C.